Lesson 4.2, Adding, Subtracting, and Multiplying Polynomials. Our essential question, how do you add, subtract, and multiply polynomials? You were given 4 problems for independent practice. Let's go ahead and take a closer look at these. I'm going to interchange both methods that we have used. So for this problem, I'm going to go ahead and use the distributive property. So 3y needs to be multiplied to 3y. So 3 times 3 was 9. Y times y was y squared. 3y needs to multiply to 8. So we have a positive 24y. This 3y has multiplied to everybody in the second parenthesis, so he is done. Is the negative 8's turn. Negative 8 times 3y is a negative 24y. Negative 8 times positive 8 is a negative 64. This negative 8 has multiplied to everybody in the second parenthesis, so he is done. There's nothing left in the first parenthesis. Everybody in the first has now been multiplied to everybody in the second, so we're done. So now we're just going to combine like terms. Y squareds can only go with y squareds, so we have 9y squared. Y's are only allowed to go with y's. A positive 24 minus 24 is 0, so those go away. And we have minus 64. So our answer is 9y squared minus 64. I'm going to go ahead and solve this problem using the area model. Because there is an exponent of a 3, that meant this parenthesis actually exists 3 times. And you need to always break it up to how many times the parenthesis exists. Please do not think that there is a quick way to go from here to an answer. There is not. Please break it up. So we are only allowed to do 2 parentheses at any one time. So I'm going to solve this parenthesis first, and I'm going to come up with a parenthesis answer, and then I'm going to do it to the last parenthesis. So doing him in an area model. So here's my area model. He had 2 parts. So here is my 2 parts. He also has 2 parts. So here are my 2 parts. 2v times 2v is a 4v squared. 2v times negative 1 is a negative 2v. Negative 1 times 2v is a negative 2v. Negative 1 times negative 1 is a positive 1. Adding all of the insides together, I have 4v squared minus 2v minus 2v plus 1. Combining like terms, so I have 4v squared minus 4v plus 1. So this parenthesis in here is a 4v squared minus 4v plus 1. Now I can do this parenthesis multiplied to this parenthesis. So here's my next area model. 3 parts in this, so let's break this side into 3 parts. And this parenthesis had 2 parts, so let's break this side into 2 parts. And we're going to multiply. 2v times 4v squared is an 8v to the third. 2v times a negative 4v is a negative 8v squared. 2v times 1 is a 2v. Negative 1 times 4v squared is a negative 4v squared. Negative 1 times negative 4v is a positive 4v. Negative 1 times 1 is a negative 1. Adding all the final insides, we have 8v to the third minus 8v squared plus 2v minus 4v squared plus 4v minus 1. Combining like terms, we only have 8v to the third. V squareds are only allowed to go with v squareds. If I had a negative 8 and I took away 4 more of them, I have a minus 12 of them, so minus 12v squared. V's are only allowed to go with v's. Positive 2 with a positive 4 is a positive 6v, and constants can only go with constants. So this is my final answer. I multiplied the first 2 together, got a parenthesis, and then multiplied those last 2 together, got my final answer. Our last 2 independent practice problems, I'm going to solve this problem using the distributive method. So 7n squared times 8n squared is a 56n to the fourth. 7n squared times a negative n is a negative 7n to the third. 7n squared times 5 is negative 5 is a negative 35n squared. The 7n squared is done. So 7n's turn. 7n times 8n squared is a positive 56n to the third. 7n times a negative n is a negative 7n squared. 7n times a negative 5 is a negative 35n. The 7n is done. It's now the negative 6's turn. Negative 6 times an 8n squared is a negative 48n squared. Negative 6 times a negative n is a positive 6n. Negative 6 times negative 5 is a positive 30. The negative 6 has now been multiplied to everybody, so he's done. Everybody in the first has now been multiplied to everybody in the second. So this is my long answer. I need to combine like terms. N to the fourth only goes with other n to the fourths. He's the only one, so 56 n to the fourth. N to the thirds only go with other n to the thirds. Those are the only n to the thirds. So negative 7 plus a 56 is a positive 49 n to the third. N squareds are only allowed to go with other n squareds. There are 3 of them. Negative 35 minus 7 minus 48 more is a negative 90, and those were my n squareds. N's are only allowed to go with other n's. Negative 35 plus 6 is a negative 29. Those are your n's, and this is the only constant. So this is my final answer, and I am done. I'm going to solve this next one using the area model. I need a 3 by 3. So I'm going to make my area model just a little bit bigger. X squared, 5x, negative 4, 5x squared, negative x, and a positive 1. X squared times 5x squared is a 5x to the fourth. X squared times a negative x is a negative x to the third. X squared times 1 is an x squared. 5x times 5x squared is a 25x to the third. 5x times negative x is a negative 5x squared. 5x times 1 is a 5x. Negative 4 times 5x squared is a negative 20x squared. Negative 4 times negative x is a positive 4x. Negative 4 times 1 is a negative 4. So combining like terms, I have 5x to the fourth minus x to the third plus x squared plus 25x to the third minus 5x squared plus 5x minus 20x squared plus a 4x minus a 4. He's the only fourth, so we have 5x to the fourth. Thirds are only allowed to go with thirds, so a negative 1 plus 25 is a positive 24x to the third. Squareds are only allowed to go with squared, so I have 1 minus 5 minus 20. That's minus 24x to the fourth. X's are only allowed to go with other x's, so 5 plus 4 is 9, and then the constants are only allowed to go with the constants. So this is my final answer, and I'm done.